Hey guys, today we're going to learn about pedigrees. Now, maybe what comes to your mind when you think of a pedigree is that dog food, right, with the little golden retriever on it. I'm going to tell you that pedigrees and genetics are not the same thing as that dog food, but they get their name, like a dog's pedigree, from the fact that in genetics, this word means a family tree of inherited traits. So if you have a purebred dog, that dog's pedigree includes other dogs and relatives that are all in the same breed. We are not going to be looking at dogs in our practice today. We're going to be looking at families, and we're going to be looking at various diseases that we learned about earlier in the unit and see how those diseases can be passed on from grandparents to parents to offspring. So a couple things you need to know when looking at a pedigree. You first need to be able to understand and identify whether a person has or does not have that trait you're looking at. So there's two categories, normal or unaffected individuals and affected individuals. There will be two basic shapes in your pedigree. You'll either see a box, and if that box is uncolored, that represents a normal male. Now, I remember that boxes are males because males tend to be more angular, right? Like a strong jaw. They're very angular. Circles represent females, and I remember that circles are females because females are curvy, like a circle. So if either a circle or a square is unshaded in, that is a normal person not exhibiting whatever trait you are looking at or whatever disease you are looking at. So the other side means we're still using boxes and squares, but an affected male will be a shaded in box. And an affected female will also be a shaded in circle. So when you look at these pedigrees, you'll see a whole bunch of boxes and circles, some of them shaded, some of them not. What else you need to know? There's going to be a bunch of lines, so you need to know what these lines mean. Any horizontal line, a line going from the left side to the right side, is going to represent marriage or mating between males and females. The only lines connected horizontally will be connecting a square and a circle. You're also going to see vertical lines stemming from those marriage lines. And those vertical lines mean that that couple had offspring, at least one or more children. These problems, you need to assign generations, their numbers, and we use Roman numerals to do that. And then each individual also gets assigned a number, but these numbers are the regular numerals that we do in like math class, 1, 2, 3, etc. The reason we have to account for generations and numbering the people, because we don't know the people's name in these pedigree. Nowhere in there does it say this is Betty and this is Susie and that's Jimmy. But in order to identify a person, we can't say, oh, the circle right there, or oh, the square right there. We need to identify them with their generation, like a Roman numeral 1 dash whatever number 3, and that's their identifier. And that makes it easier for us to talk about a person in lieu of their name. It's important to know that when looking at a pedigree and interpreting it, you are only interpreting phenotypes. Remember, physical characteristics. It only tells me whether a person has or doesn't have the trait, but it doesn't tell me what their genotypes are. And that's the purpose. We need to figure out the genotypes of these people. And to do so, you need to read the problem. It will tell you the type of trait or disease that it is, and you need to know how that trait or disease is inherited in order to solve the problem appropriately. So it's going to, again, come back down to reading closely. If you pay attention to what the prompts say, you should be able to solve the problem accurately every single time. So how to solve? There are a couple different pedigrees that we're going to be learning about, and so I've got them broken up. The first is autosomal traits. Remember, autosomal traits are traits found on chromosomes 1 through 22, like your hair color. So the first step to solving an autosomal pedigree is to identify the numbers and generations of people if they are not provided for you. Second step is to read the problem. So I go ahead and number the people and generations even before I read the problem because I know I'm going to need that information later. After I've identified them, I then read the problem. I identify the inheritance of the trait and determine whether it's autosomal dominant or autosomal recessive. Because if I'm talking about a dominant trait like rolling your tongue, the shaded in boxes and circles are going to have different genotypes when compared to somebody who's some problem that has an autosomal recessive inheritance. I then, for an autosomal trait, I identify the people who are affected. And then I figure out the remaining genotypes of all of the people. And I can do this by analyzing the parents of the person, if they have parents, and the children that they have. Because remember, each person in a family is going to get half their DNA from both parents. And then any offspring they have, they donate half of their DNA to their offspring. So you should be able to see trends passing along between families. The last thing you will do is to identify any unknown genotypes. Now, a person with an unknown genotype is going to be somebody who you know has the dominant trait, but you can't determine whether the second allele is another dominant allele or a recessive allele. Either way, this person, regardless of if they're homozygous or heterozygous, they would still be expressing that dominant phenotype. And so they would either have or not have the shaded in circle or square. But without knowing their parents or if they have children, we can't determine whether they're homozygous or heterozygous, so we don't assume. We identify them as an unknown genotype and we leave that with an underscore. And that tells me that you know the person has the dominant phenotype, but you are lacking information to determine what the second allele is. So I want you to take a minute and draw this pedigree. This is a pedigree for albinism. I've already gone ahead and identified the generations. I would like you to go ahead and, besides drawing it down, also write down the numbers for the people. I hope I have enough space. You just go ahead and you start with each person in the generation gets a number 1. And you count across. 2, let's go ahead and start solving. So this is this pedigree is representing the inheritance of albinism. Now, if you recall, albinism is autosomal recessive, which means that to be a shaded in box or circle like this one here, 1-1 or 3-1 or 3-5, that means that your genotype must be recessive. So I have to have a lowercase a, homozygous lowercase a, for every single person with a shaded in box or circle. So that's what I'm going to do. I labeled generation 1's genotype. I'm now going to go ahead and label 3-1, 3-5, and 4-3 with the same genotype, because if they're all albino, that's the only genotype they can have. So now that I've identified their genotypes, I go back and I now have to figure out everyone else's. So if they're not shaded in, they all have at least one dominant allele. And my job right now is to figure out whether their second allele is also a dominant allele or a recessive allele. And this is how you do it. So let's start at the top with 1, 2, and this person, this male right here. He has a normal phenotype because he's not shaded in. So that means he has a dominant allele. And I look at his parents. Well, his parents are missing from this pedigree, so they're no help. I look and I see that they have one child. Okay, that one child also has a normal phenotype, and I have no more information. Because I have no more information, he is an unknown genotype. What would help figure out that second genotype, that second allele in the genotype, is if he had a parent that was affected with albinism, or he had a child that was affected with albinism. That would give us that second allele. But since we don't have enough children and we are lacking his parents' information, he's unknown. Now moving on to generation 2, 1. This female inherited her dominant allele from her dad, and her mom had to give one allele, but she could only give one type of an allele, the recessive. So that means that her genotype is going to be heterozygous. That's also verified by the fact that she has one son who is also albino. Now, if we look at her husband, he's normal. We see that he has 3 children with her, but we don't have his parents' information. But because he married another woman who was an albino and had a child that was albino, he is going to be heterozygous as well.